don't need a monitor. This thing, yeah. Out of nowhere it called him. Thanks for telling me. I keep missing that. I'm thirsty too. Let me get a glass. Go right back. Oh, I have a glass here. Yeah, so that's how it works. Now I want to be able to draw the coordinate system itself. We're going to automate that, obviously. This draws the rectangle. Now I want to draw the coordinate system. I think I want to draw the coordinate system first. And then we draw the rectangle over that. So let's draw a coordinate system here. The frame? What do you mean frame? Is that called a frame? Yeah, okay. I've been calling it coordinate system all over the place, but I'm not English, so I meant the axis. Yeah, so you have two axes. Usually the x-axis and the y-axis with little marks on it. The tick marks, I think they are called. Whole axis, not just the arrow. But okay, I can add an arrow on the positive x-axis and the positive y-axis, yes. Is that not called a coordinate system? Is that called, how is that called? No, it is new Vim with heavy customization. No, I don't know, just configuration. Or do you mean the graphics? That would be my own thing, partly. No, you're not answering, damn it. Coordinate frame, then they call it a coordinate system. I think I'm going to go for coordinate system. Yeah, type frame and then I get coordinate system. And here as well, I think it's system. Dot files on my Git? What do you mean? I don't like to use the prefix draw here though, because I have a coordinate system called draw. and I have a coordinate system called show. Yes, is about Qt. I'm using Cairo window now though. I'm using Cairo window, which is my own project, yes, to draw stuff. The only thing Qt about this program is the fact that I'm using Q transform. I have only on GitHub the coloring stuff, syntax coloring. If you search on my repository page for no, I can't think of the word. I need a synonym for draw. Also already used it. Every word is already used. Paint. I'm gonna use paint. Nah. Another one. Display. Replace this on display. Change this one into display as well. Can't change this door though. But whatever. Okay, what does comprise a coordinate system? No, this is not using the Vulkan engine. It never finished that. It's not unusable. Well, thinking the coordinate system, the only thing I have defined are the transformations between two coordinate systems. And I want to draw one in the pixel coordinate system, obviously, because I can only draw pixels. So what I should pass here is pixels transform draw. And every time you use this, you must pass pixels. Some pixels transform something, and then it will draw the something. So now we can, everyone understands this. So I have a transform, for example, this one. This is a matrix that, oh boy, I really work with column now. Maybe I should swap them as well to more match how the way Qt is doing it. I think I should. I mean, this is the only thing that I really have. But how much impact is swapping swapping this and this. Going to have. I think I have to swap these two as well then. So just swap the template parameters of transform. That might be it. No, and I have to swap these two. Yeah. I think I should do that. Let's talk about C++. Okay, I think I'm gonna do that. So, git status, let's first commit this and then make that big change. I have no idea what this included before, but it used to work. I think I had the fake idea that every project also has a config.h in the root of the project, but I think I'm no longer thinking that. So, and even if it does, the only thing I'm interested in at that point is the utils config anyway. Wait a minute, yeah, push it. Okay, so git status. Where are we? Transform. Git status. Git diff. Some kind of description. I added enchantum and qt and basically all the code. So let's call it VIP. Work in progress on draw coordinates. Now let me change this. That's a big change. So you have to swap the template parameters, the binary multiplications, and the variable names. Let's begin with the variable names. put that at the end here too. I have to also swap. Yeah, I don't know. It's just the variable names. That was draw. Then we have centered. That's a lot. It's too much to do one by one. Can I automate that? Substitute centered underscore, I think backslash, A through Z, A to Z, 0 to 9 or underscore. Yeah, backslash 1 underscore centered. And it puts the centered on the other side. And then the last one is pixels. Now that should also be just that prefix everywhere. I might as well do that file-wide. So that's the same thing, except now we use pixels, so it must be file-wide. So it should put percentage here and then pixels. Pixels. Oh, what? The transform got renamed now. Well, this was pixels. Pixels transform centered. So pixels now moved to the other side, while centered wasn't moved yet. I can fix that manually afterwards, I think. So let's do this change. And indeed, then I have a transform. To the centered now must be up front here. Then also this printing must be the other way around. I guess the 2 and the form are still the same. So we just swap this. That is, we put say front first and then 2 second. And I think then I have it. Let's look at the div to see what exactly changed now. So we have this transform and then the prefix is now the suffix and the other way around. And here I didn't change the template parameters yet, but here pixels and centered were swapped. And those were not swapped. The rest is the same. And here that is not correct. Centered is not, has not been moved to the end. Why? I thought I looked for that. No, that should have been automatically. This was swapped. Centered and pixels have been swapped. And here again, centered is not been moved to the other side. Again not, and here they are swapped. Pixels has been moved to the other side. And here centered has been moved to the other side. And center and pixels have been inversed, and pixels moved to the other side. The center was moved to the other side, okay. Move to the other side, what is this? Auto? Oh, here. Yeah, this is not correct, so this draw must be moved in front of transform. So I just accidentally used the capital T here. Or maybe not accidental. Center was moved to the other side. This is still not correct, but that is because of the capital T. And this is moved to the other side, this is moved to the other side, this is not moved to the other side. Again, the capital T problem. That was moved to the other side, this is moved to the other side. These two are swapped. Display the object on center was moved to the other side. That is still the same. That is good. Now be gone. Segment is just that was moved. Yep. This is moved and that is not changed. Then we have a problem with transform underscore. Where I want this to be a lowercase anyway, lowercase t. And I have some centered underscore prefixes that have not been moved. So this must become centered on that side. Oh, wait a minute, that one was good. Centered. Yeah, this is drawing the coordinate system. I was running that. Draw transform pixel doesn't exist yet. Let's comment that out for now. Good. Then the operators must be swapped. Operator star. Yeah, so this is transform times point, but now we are going to change that. It has to become a friend, so I'll make this a friend, and then the transform moves to the other side. I'm just going to use transform, I guess. Shit, I'm pressing the wrong key. The transform now is on the right side. So instead of transform times size, we have size times transform. Because that's how Qt does it. And this is already printed like that. Okay. That were the multiplications. Then the template parameter must be swapped. I think that was the last thing. And that's just a template of transform. It's the only one that has two coordinate systems. So this does become from a front and to here. I'll just copy this. And then of course everywhere where transform is using it. That is to from, 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 to from. There is something else. I have to swap these as well. See how many those are. That's the third one. Oh, it's not that much. And we went around. So let's just do these first by value. Just swap that as follows. It must be 2 and this must be from. And then we have these. This must be now centered comma pixels. That should be it. I don't like it and that there are mistakes. Non-member function cannot have const qualifier. Well, okay, that's at least not a typo. It's just a friend is not const, cannot be const. The const is now here. Use of undeclared identifier convert from. Did that compiled before? Why is it suddenly no longer compiling then? Oh, that. Huh? Yeah, likewise. Oh, because it's a friend. Yeah, I get it. There was a member function, therefore it knew where to look for the convert from. So you have to qualify that as well. Same thing here. Let's put those on a different line, on a new line. The arguments. And more const for the friends. These are now free functions. Undefined reference. That's interesting. Must be one of the free functions which I then did not initialize. That is a operator that multiplies a size with a transform. And indeed it is that order. And this was to from, and now it's the other way around. Maybe I forgot to swap these two. Yeah, I think it doesn't work because indeed this should be 2. And this 1. So there is a multiplication somewhere that is wrong. In here. Rectangle 2 window. Don't really see the problem. This thing is centered pixels, and they should now. I swap these and I swap these, so they should still be the same. So you have centered first and then pixels. Here also centered first and then pixels. And these were swapped, therefore the center is still short circuit, and they do that in both cases. And then this should short circuit, so we should end up with top left pixels and size pixels, which you then store here. And indeed, there's our pixels. So everything looks totally fine. What is wrong then? Undefined reference to operator start of a size coordinate system 2 with a transform coordinate system 1 coordinate system 2. True. True means inverted. So I'm multiplying somewhere with a matrix that is inverted. I think that was inverse. That does not look good. You can't multiply pixels against centered. So actually you can if you invert it. So the inverse would cause these two to be swapped. So then it is again pixels times pixels. Okay. Now we might as well define a divide by actually. But okay, let's keep it like this for now. So inverse should return something with swapped coordinate systems. And it doesn't. I forgot to swap these two. So the current object is from to, and then if you inverse that, it must be to from. Did I forget it in other places as well? Or see how many to froms we have now like this? None. Yeah, I think. Oh, I remember. Yeah, I just took this pattern and then swapped these two. But I did not swap existing patterns that were already like this, which actually only occurs for the inverse, hopefully. But type save, it won't compile and or link until I got all of them. Invalid operands to binary expression. Size pixels and transform coordinate system 2. What? Okay, centered transform pixels is centered pixels, and then the invert on that swaps them, so then we get a transform pixels centered. Or do we? No, that's a good question. Maybe my last change wasn't correct. No, it wasn't. Sorry. Yeah, it was not. It was not correct. There's something else that must be changed. This was this has to be from too. Okay, so this from point to point, from point convert from to point convert to. Also from size from to size to. And the transform is templated to be by that. Which I guess is just any transform, more or less. I don't see it. Things look good, man. How can this suddenly stop working? There seems to be a multiplication in rectangle 2 window between a size and a transform that is inverted. Now the only multiplication is this one, but that is a multiplication of a size with this, which is, it's not inverted. Nope, I think it is. Must be this one. Let's replace this one with a identity matrix. Which doesn't exist. Size of width and height. Yeah, I didn't give that a. It's not a matrix to begin with. Well, no, it's not inverted. It's still undefined something. We have to start to do a binary search, I think, in the source code to find the line that causes this. Yeah, I find it. I found it. This is wrong. No, it's not. Sorry, it must be swapped. It's now from 2. Yeah, everything looks good. It's really weird. I'm curious what it's going to be, because I did really not see it. No actual program. That works. Well, we can remove stuff from the bottom, not from the top. So let's put that halfway. Well, halfway including the comment. It's nonsense. Let's put it here. It's more or less halfway. Now we have an undefined reference. Let's remove that block as well. Still undefined reference. So it must be in this block. Well, cannot be the debug output, obviously. Undefined reference. So now only this line has been commented out. Extra. And now it links. We can hopefully fake that line and then see that the rest compiles. But I think I already did that and then it also didn't compile. I'm gonna fake everything, I think. I'm gonna get rid of all problems. So give this a size 1, and then it doesn't work anymore. So let's comment out everything again, except now this line. And that works. So it's probably going to be this multiplication here. So let's put it right in front of it, which should still link. And then one down, now it should no longer work. And now we fake that one as well. And that compiles and links. And then we enable everything again. Oh, still undefined. What? So get an undefined operator star. I'm not even doing any multiplication here. Oh, maybe the multiplication is done here inside this thing there. Yeah, I think so. So if you comment out that one, that indeed, then links to, there is another one, probably in the instantiation of this rectangle here. Which instantiates this one, and there is a multiplication, 2 even. There is no multiplication here. So what if we fake these two? So I'm just beginning with faking both. Actually, so let's just comment that out. Top left centered. Good. So there is conclusion. Not a single multiplication works. Now let's begin with the simplest multiplication. Hello, Alt R. Where is my simplest multiplication? I think this one. Yes, so if we do this again. Yep, undefined operator star 0.0 with transform 0 1 false. That is 0.0 should be the draw original draw origin draw, I mean, which is indeed a point, and draw here is 0. So that type is correct. With, what was the other one? Transform 0 1 false. So this is a transform. 0, 1, false. Well, it's false because it's not inverted. And the 0 is still the draw, and the centered is 1 then. Yep. So this is multiplying indeed a point draw with a transform draw centered, and that should work. And I should be able to find it as well. It's gonna be something extremely stupid, you know, we know that in advance. But yeah, okay, point something times transform with the transform is not inverted, it's just the same as this one. Actually, it could be inverted. I want this type to be the same as the first template parameter of transform. First template parameter of transform is from CS. This is converted from. Converted from is from CS, is if inverted is false. Inverted was false. So converted from is equal to from CS, which is the first one, which was draw, which is 0. So this is, are we talking about point or size? Not that it matters. Both are the same. So we have a draw, it's 0, and a transform, 0, 1. That's defined, that's why it compiles. But apparently I'm not defining this. Point, it was point. Well, it should be defined here. The whole idea is that the friend is defined here. So apparently this is not resulting in what I think it should be resulting in. Let's begin with comment and get out. That should not make a difference because it didn't exist to begin with. Might as well comment out the other one as well. Same problem. So what am I doing wrong here? Nothing. It's correct. I don't see it. Why is this not instantiating the function that I want? Oh, I know the trick. Aha! I know a trick. The trick. We're going to remove the friends. I mean, this thing needs access, but hey, that's the second problem, right? Yeah, well, I'm going to remove this point friend here. So now, before it compiled, because it sees this friend and then says it's like a for declaration of a free function. And it says, okay, the thing exists, so compile. And then the linker has a problem because it doesn't exist. But if I remove that for declaration, then the compiler is going to complain, which is probably going to be way easier to understand. So now you get an error right here. Which I restored again before we did 1.1, but this is not working, apparently, because, and then you get an explanation why it is not working, because it cannot find a free function that is a multiplication between a point draw and a transform draw centered, but it should find that. And then we get a list of all candidates. And then we see which candidate it has. Well, not this one, because that's the size. And not this one, because that's /user include. And it's not there. Okay, wait a minute. I commented it out. There was another one. No, I commented both out. Sure, they are both commented out. Let me comment them in again. Let's still comment out the size, this one. It should definitely see this one and now reject it. And then it's going to tell us why it's rejecting it. I'm so curious what this is. I cannot imagine it. And it finds it. Okay, I think I have a clue now. The friend invented a new function. And not where I thought it was. So I think I don't know what it did, but it is it's definitely not this function. It did hide my function even, I think. No, you should be able to see that here. Where the linking goes wrong. It looks like a free function to me. This is just in global namespace. So weird. Maybe it rejected it because it couldn't compile it. Oh, that might be the reason. Oh, that might be the reason. Okay, and now it's complaining about that it's a private member because it's no longer a friend. And then it hides the other reason that it rejected it. So we're going to make it public. So that problem is gone. Now it doesn't need to be a friend. Let's make this temporarily public. Yeah, and they have the same effect as that it was a friend. And then it's still rejecting it. Oh, that's why it's rejecting it. Yeah. But if it was a friend, that would also not happen. Wait a minute. I have to make that public as well. Yeah, let's make these public as well then. More friend stuff, basically. And now the links. You couldn't be kidding me, right? Starting to be pissed off. Okay, add a friend back. My guess is now we get a linker error again. Yes. So by adding the friend, it makes up a function that in the end is not the same function as that we try to link with. Which makes little sense to me, actually. Really. Now I want to see the mangling of the two symbols and then see that they are different, and then I want to find out why they are different, because this is really annoying. So to find a mangled symbol that is missing, we have to look in the actual object file of this, which is now clearly here. That would be this. Cool. So you can do read elf symbols wide build dir slash that object file, and then we are going to look for I don't know, let's write to a file. I'm not sure I can find it back like this yet. Let's first demangle it. Demangle. And now we can look for something that is called that. Well, not really, because well, I don't know. Let's I don't know what to escape here, because it is a regular expression. Yeah, just a star probably. Just a star. Okay, we'll point here and a double, and then it must be this one. Yeah, so we have an undefined operator star between a point and a transform. This one. And that's at line 627. So now we're going to write this again, but then without demangling. And then we go back to, what did I say? 227 I hear myself say, but I'm not sure anymore. Nope, I forgot. Oh, 627. Looks like something else. Funk week. Oh, this one, undefined. I don't know why we end up there. 627, still at the same place. This thing is undefined. That is the symbol that is undefined, and you can check that with C++ field. Yep. So we have this as undefined symbol. Next, I'm going to remove the friend again. And now it does link. So now, if you do read symbols, demangle, write it to troop, or write it to troop 2. Then we should have an operator star. Looks totally different, I have to agree. Operator star. It's a template now. What? Oh, the free function itself is a template. Yeah, it should be. I think this is the one. It's a template between a point and a transform. 0, 1. Then a point 0, 1. Yeah. So totally different. Totally different. It's a totally different symbol. Okay, 635. Well, I can try this here. I can do it. Let's get the symbol. 635, right? So this is the symbol that we actually link with. In the end, this is a totally different symbol. And then if you demangle those, then the one is that, and the one that we get or have is this. That's very, very, very different. This is a function without a return type encoded into it that takes a non-template point, and a non-template, well, it's a template, but it's already filled in, right? I'm so confused. The operator itself is not a template anyway. And here it is. How would I create then the non-template operator? Is that even possible? Yeah, this looks like a specialization. I wouldn't know how else to make this thing. But on the other hand, isn't a template that is instantiated having the same symbol anyway? I still don't get it. There is a lot of confusion, of course, by the fact that this thing makes a detour through transform. It takes a transform and then the convert to of that, which is totally defined. So how that ended up in the type, that's pretty weird. Is convert to not a static const expression? It is a static const expression. How can this end up in the type then? Shouldn't it expand that? Well, I only know one way around this, which is what I usually have to do, and that is forward declare these things. Then the friend suddenly will pick up the forward declare thing, and then it does work. So, but I mean, why? Why so different? Well, they really are the same thing. Blip. To forward declare transform. Oh, maybe that's the reason. I don't know. Nah. It's over my head, I'm afraid. Holy moly, and still it doesn't work. I had not expected that. You know what? I think it's a compiler bug. So seriously, this is not how it should work. It should have worked. And I don't have time and motivation to report it. So what we're going to do is we don't use friends. Don't use a forward declaration. And I'm just going to add an accessor for this to get it over with. Let's make that private again. Now cleaner would be to just put this in a member function. So convert the operator to a normal member function and then have the member function implement that. Of course, a member function is automatically a friend, obviously. Can we do that? Is this somehow a neat member function? It's a right multiplication, so I call it on transform, but then we multiply it from the right. So I could call it multiply from right, maybe. I think I'll do that. Still has to return the same thing, unfortunately. Now make this a member function of the object. Now we call it multiply from the right, whatever. And then we pass the point, but not the transform, because that is then the this object. I think now I can leave out this and just use convert from. Yeah, let's put it below that so compiler can decide, or has it easier work with inlining it if it wants to. I don't know, I like to define what I call first. I don't know if it even makes a difference for templates. So I do the same thing here. Start with copying this. And then make this something that does not take transform. I'm so confused again. This goes down anyway. Yeah, I want to keep this one and then do a return transform dot multiply from the right with size. And then this must return the size still. Yeah, this is now an member function of that thing. Taking a size. Or we don't have to pass that. Yup. And then we have to add these two to the class. As a replacement member functions for the multiply. No longer need this. I think I do point first normally. Too few arguments or class template transform. How did it end up like that then? Oh, it's not too few. I just removed the default for inverted. Well, the last thing I removed was for declaration. Valid operands to binary expression, point draw and transform, draw centered. You gotta be kidding me. Candidates. Ignored substitution failure with from CSS draw and to CSS centered, inverted false, because convert to is private member. And we found the reason. This was the reason that it failed, I think. Well, you can't access this. Also not if it is defined as a friend, because it's the return type. I think it has to do with that, yeah. And that was hidden when I tested it as a non-friend again, because I made it public. And then suddenly it didn't fail on this. Now finally it shows us why the template wasn't used. I think this was the whole thing, yeah. So you can't just use convert to, you must qualify it with the whole class, the whole transform thing, even though our operator was a friend of that, because the return type falls outside the friendship thing. It doesn't know where to look for it, you just have to specify it. And then it was like, yeah, I can't use this template because we can't access that. So it did not have a return type, so it was skipped. And then it's still compiled because when that failed, it created a specialization from the front. I think that's what happened. Yeah, well, are we going to go back to the friend definition? I don't think so. Let's just make this public. No matching member function for call to multiply from the right width. Template specialization. This argument has type const transform, but method is not marked const. Okay. So we had to remove the const for the friend stuff, but now we introduce again member functions. Yeah. I think we get garbage now. Yeah, we get garbage. That is, we get nothing. Because I still left in a lot of 1,1s. And we're back. And the only thing I changed now was those swaps. Status get diff. Yeah, I'm just leave it like this, I guess. I don't feel like putting more time into it because it's just a test application. Not so important. Git commit. Let me think. Oh yeah, so I was about to do this. Display the draw coordinate system. And it can now, I just say display coordinate system and we pass the layer that has a draw on. And we pass the transform from draw to pixels. It is now. And now we have to invert that because we know the coordinate system for pixels, but we want to draw the one for draw. So, okay, we just do it like that. And I have no idea how yet, but it definitely means that we need a free function called display coordinate system, which takes these arguments. And then it can draw any coordinate system. I probably need all our machinery here, like transform and everything. This is a new thing, so let's put it somewhere at the bottom. I'm gonna put it all the way down here, just before main. And what is the type of layer? The type of layer is auto. Well, probably just layer. Actually, layer. This. Is that thing const? I doubt that. Let's see what. No, I have to draw to it. Cannot be const. What is a layer actually? A layer contains a load of stuff. Oh, it's an auto. Yeah, it's a boost pointer. The auto. It was a create, I think. Yeah, create. Yeah, so I have to look at the create background layer. A boost intrusive pointer. Might as well pass that by const reference instead of incrementing the atomic. And this, the draw transform pixels, that is a transform, which is a template. Class transform. But then again, we are going to display it. So this is insisting really that it ends on pixels. So we don't need the 2. The 2 is always pixels. And we don't need the inverted either, because I don't want to talk about inverted. It's just always not inverting. Is that true? Actually, I could also accept pixels transform whatever. That would be actually even be easier, so I'm gonna do that. I'll just demand that it starts with pixels and that it is the inverted version. And so that is from to inverted from pixels to whatever, to coordinate system. Yes, because transform is now from to, in that order. And this also, this is the same order. So we put pixels here and CS there, then it is from pixels to CS. But this is the inverted version of that. Actually, it's easier for me to work with the non-inverted version of this. I don't know which way I want to transform, or maybe both. If I have to transform in both directions, then no, I know the coordinate system of my window, and I want to transform that to. What do I want? I want to draw lines. So. No, I want to convert from CS to pixels, because we have to draw pixels. Yeah, I think I made a mistake. It's more from. I want to convert from arbitrary coordinate system to pixels. Like this. So now this should compile. Oh, I don't have a draw transform pixels yet. Okay, let's create that one then. So I want to create this, and that is, well, what do I have? We have centered pixels and draw centered. That's close enough. And there we have it. I introduced multiplication between two I've got the word. I laugh, but it's deeply sad. Transform. So I need to be able to multiply and transform with the transform now. In order to be able to do this. Yep, okay. No, operator star. So we have a free function here, that this no longer needs to be a free function, because this is a free function because the transform is on the right. But now we have two transforms, so we also have a transform on the left, which means that we can just make it a member function. Might as well. So I'll put it in the neighborhood of that in the class, and it's going to return well, a transform. I don't know what yet, something, and then this is going to be an operator star multiplying the current object with a new transform. So now we have this object multiplied by this one, though this one is first. And the one that comes first is applied first in this with this ordering, like just the way Qt does it. Therefore, the real beginning is this from, and this is the intermediate 2. So the final 2 is something else. But the from of this transform must be equal to the 2 of this transform. So this transform here, this one is applied first, so we go from coordinate system to the 2 coordinate system, and then by this multiplication we convert that from the 2 to this 2 to yet another. So let's call that well, the final CS, or the result CS maybe, I don't know. Final, it sounds so final. And then the invert is also unknown, or not. No, wait a minute. You can not. You cannot multiply an inverted transform, I think. Actually, you can. No. Well, do we? Can we? No, we cannot. I'm so confused. I think. It also depends on if this is inverted or not. Not to mention that these values depend on if it is inverted or not. This story only holds if it is not inverted. So in terms of the specialization, it should be false. Let's just call it the right hand side. And I can make it const because we're going to return a transform by value. I think we can make it extra complicated. We can make this an auto, which in itself is a template. So we have now we have a templated member function because it's auto inside a template, and then I can add another template in front of this. There's 3 templates within each other. No, it's actually not necessary. I can just use invert here. Inverted. So now we can multiply a matrix that is not inverted with a matrix that is not inverted. And we can multiply an inverted matrix with an inverted matrix. Not an inverted matrix with a non-inverted matrix. Although that doesn't sound completely impossible. You can only invert a matrix, I think, when it is a square matrix. And you can multiply a matrix with its own inverse. Then you just get the identity matrix. Maybe I should allow multiplying stuff with its own inverse. Yeah, of course we should allow that. The only thing that really matters is that the coordinate systems match. So I'm going to have a separate inverted. This must be a template then, Boolean. And that is the right hand side inverted Boolean. So that is the right hand side, and with the right hand side inverted. But now these two values here. One of them must match one of these. And the other one is then also templated. That is just whatever the result is. So we're going to have an output coordinate system. And that is then the result coordinate system. Now let's make a list for every possible combination we need. If we have two non-inverted matrices, then okay, say let M1 be non-inverted and convert from A to B. Let M2 be non-inverted and convert from no, let's do B, that doesn't matter. B to C. And we use QT's thing, so these matrices are what is it? Well, basically the transpose of what you normally would expect. We multiply them from the right with the vector. And I say from A. So in the end you get something like vector A multiplied with the matrix. And to use my notation, I want to then short circuit that with an A here and then 2B. And then put that in the name. So A M1B is a matrix that converts from A to B. And this one went from B to C, so you call that like that. And then we can multiply the whole thing with that, which is then V expressed in C. So I'll put it the other way around, so V expressed in C. Or, obviously, AMC is that. Let's call that M1 too, whatever. Just coordinate transformation, we remove the intermediate coordinate system. And this is for the non-inverted case. Now for the inverted case. Thus, let be an inverted matrix that converts from, and I think A and B just swaps, right? I mean, if you invert it, then you can multiply it with itself. So if I can multiply this with that, then this must actually be something that ends on A. So this does the conversion the other way around. So it's now going from B to A. And we'll probably also need the inverse of this one. But I want to, don't have to use these really, because I just want to combine them with in both inverted and non-inverted matrices. So I want to be able to multiply these two together, but also each of them with one of the non-inverted ones, and then actually from both sides. So probably I need some multiple of these. Say, and therefore notate them as B something A. So I need M1 in it as a label, and I want to know that it is inverted, so I just take an I here. The I of inverted, like that, M inverve A. So now we know again that we go from B to A. That's just easier to work with. Denote, I think it's. Denote. Now, ignoring the fact that it is inverted, I want to end up with a multiplication. You have the multiplication between two non-inverted ones. I want to have a multiplication between two inverted ones. And that's not going to be the inverted of these, unless I invent an inverted one that begins with an A or a B. Or actually I can. We can just multiply this one with that one. Yeah, we can do that. So I don't need a new one yet. So we can multiply this one with that one. The B's can connect. And that then will give us, I suppose, C, well, something else. I'm going to call it C12 inverted. It's also inverted. Inverted times inverted is something inverted. Is it? Well, this would hint very strongly to that it is the inverse of AC, aka the inverse of this. Is that true? I think it is. If you take, just mathematically seen, if you take the inverse of this, then you get, that is the multiplication of the inverse of that with the inverse of that, and then swapped. So this one comes there as the inverse, and this one comes up front as the inverse, and then you get this inverted. So yeah, totally correct. Didn't need anything new for that. And we have also the possibility to multiply a non-inverted. I can multiply it with itself, but that's a bit boring. let's introduce something else. Let okay, let's have an inverse up front, which we multiply with this. So that is then M3. M3A, so I can multiply it with this one. And C on that side. Oh, wait a minute, this must be an inverted one. Be an inverted matrix that converts from C to A, huh? And then I want to have one that can be multiplied, let's say, with the other one from the other side. Oh, that's the same thing. Okay, I don't need that. So then we can write down stuff like this one times this one. But what does that give? Something. I have to think about that. And we have, let's say this one, we can multiply that one with this one from the other side. So when you have non-inverted multiplied, two inverted multiplied, and an inverted and a non-inverted multiplied in both directions. And every time there you have the short circuit between the things that are close to each other. So two A's, two C's, two B's. That should work. And the comments say what it is. And in order to know what notation comes here, I rather go back to the mathematics, although I'm not super familiar with this transpose notation, or what is the word for it? Is there row order or major, row major or something? Column major? I don't know. Probably one of those. So the first line here is actually the inverse of AM3. Sorry, AM3C inverse. And this was my notation for the inverse of that, as you can read here. Went from there to there. And we multiply that with this. Okay, that is confusing us because of the inverse. So we have something. This dot 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 is the something, and that is equal to this, I say. So we can write that like that. Now we can multiply both sides with this matrix from the left. It should still be correct. And now these two cancel because they're just the thing implied multiplied with its own inverse. Now if I would use A M3 C, if I would use C underscore M4 B, then we would get A M34 B, because then these two would short circuit. And before I use the notation that if you have a multiplication between two things, M1 again times M2, then I call that M12 apparently. So okay. So where then the M4 must be extracted from M1. Or I can just replace this with M34. Why not? Because it's just a tag for a sum matrix, and the coordinate systems are more important. That's what it's really about. So putting M34 here, it becomes easier than this is this. That's interesting. So now not just the A's are eaten, but the M inverse eats the 3 here as well. Apparently. Cool. So this must end up as M something, A. And now I bet this time the M3 inverse eats the 3 on that side. So we can call this 4-3, whatever, 5-3. And then this is 5. Now I did have an M3, I think. Oh, no, I only had an inverse. But we did. Yeah, wait a minute. Let's write this anyway. Let's define it the way it had to be defined. So this is CM3A inverted. So now this implies the definition of that. Now the A is on the wrong side, sorry. Oh, dang. Must be the other way around. I need an AM3C. How did that happen? Oh, that happens here. I have to change these things. Okay. Something times M3C. Yeah, so this must be an A, this must be an A. Do we know what BM5A is? Well, that is this. Oh yeah, okay, I just used them back. Awesome, okay. Now, can I now write this function? I think I just have to write it out. Let's write it out, the specializations for each of these cases. So I should have 4 cases. That's 1, 2, 3, 4. Let's give them a number. So the object on the left is the current object, which means that from CS is the first type. So from CS is this one is B. Yeah, the current object is the one on the left, and then the first thing is the from, because we multiply from the from the left. That's 2CS is C. And the result CS is A. So the C is in the middle. So the specialization would be, maybe you just do this and then add specializations first. I think in the end you can then change specializations again with if const expressions, which I would rather do. But I can't wrap my head around it at the moment. So the specialization for 1 would be 2CS is C, A, false, both is not inverted. But only enabled if inverted is false. Okay, do standard enable if or something like that. But it's probably not going to work. Well, maybe I do know the return type anyway. So enable if inverted is not true. And is it not like returning a type only if this is true? So we can fill in the type here, and that is then the transform. Really? All over the place? I just do. Let's watch from next. From the beginning. Yeah, good idea. It was a good series. I think there's even more now than I watched. I don't know if it works. Does it work? Do I have to look it up? Yeah, probably. Yeah, let's look it up. Enable if. Enable if T probably, or this one. So that probably returns the type T if and only if B is true. And that return type is well, this is the result of 1. So that is this type here. which converts from C to A and is also not inverted. I mean, why would it be? Probably should never return an inverted type. Then I get the specialization for 2. So that is only enabled if inverted is true. And we have a transform. This is then the non-inverted result of the multiplication of 2, which is swapping A and C. So I'm going to actually what? Yeah, I think it just is the. This is the defined as the inverse of A M1C. So no. I think that's still from C to A, actually. That's what it is, man. I don't care what is here. It is also from C to A. And I might tag in an inverted if it is easier to calculate M1 too. Which might indeed be easier because I have M1 and I have M2 with a boolean that is true, but who cares? So we have a BM2C and we have AM1B if you ignore the boolean. And then I can still kind of here note that AM12C is easy to calculate as AM1B times BM2C. You see how important it is to have your notation correct? So I invented this like many years ago because then I wanted to do lots and lots of coordinate transformations in LSL coding, scripting in Second Life. And that was one of the hardest problems that nearly nobody understood. And I really went down on it. Well, if you know me, then you believe that. And the result was that the only way to do that, the only way to write code involving coordinate transformations is if you use this system. And see how easy that is. These are insanely difficult to follow transformations, really. But just by using the correct notation, the correct variable names, it's just easy. I don't have to understand it anymore. I just short circuit what is in the middle, and then you get AM12C, and that's all there is to it. And suddenly it's easy. That was so important. That is the whole trick. So since this is the inverse of BM2C, and our inverse is just a boolean that I can ignore in the template parameter, we have BM2C. It's same for this one. So we have this and this thing, and we can just multiply it, and then we have that one. So and then I tack on the boolean again to return this. So I think that it is going to be easiest to return something with the boolean turned on. So the result is something that is inverted. And then the left hand side, so 2 is the left hand side of 2 is this thing. So that means that the from CS is equal to A. And the 2CS is equal to the intermediate, again, B. And that's all. It's always going to be the intermediate, because 2 from is the left matrix. No, not true. Actually, it's not true. It's not even true in this case, because it's inverted. Yeah, no, that's not true. Because the left-hand side now is inverted, it's actually 2 and from are swapped. So this is B and this is A. And then the result here is obviously 2C. And that looks very weird, because A is here. Does it look weird? Let me think about this. B is short-circuited, yeah, so that should be the intermediate one. Yeah, so the B is the intermediate one. But if you multiply this from the left with a vector defined in coordinate system A, then that is obviously the coordinate system that you start with. So the from. So this should be the from. But it is the 2, and the reason is that our 2 is named wrong, because the real 2 is this one, converted 2. So maybe I should use converted 2 to be less confused. But in the end, I'm gonna need these. So yeah. To encode that in these two is a bit, I don't know. I could call it the left hand side and the right hand side maybe. first, last, first, second. Yeah, what is a good name for it? Template parameter. The first template parameter is, yeah, either to or from. It's just what it is. Unless, of course, I just change the meaning of them if the boolean is toggled. So the first one is always from. Maybe that's easier, but then I have to change. Yeah, I have to change something, but it feels better, right? I should change this. Yeah, I should do that. Okay, the big change. It's never easy, is it? I think it's dual, but I probably also should test it. So before I change it, let's make the compile. Which means I think I have to comment this out here. This stuff. So that's not yet compiling. So we can't do this, we can't do this. This compiles. Yep. And works. And then I want to swap the meaning of the first two template parameters if the template has a true boolean as inverted. And I think I never pass false. I do, well, that's the default. Okay, but this is commented out, so let's not think about that yet. And do I ever pass true? Also commented out. There it is. There is one true here. Okay, there is one true here. Display coordinate system. Oh, I'm also still working on that. Let's comment that out then. So I never pass through. So then the only way I get my inverted is by calling inverse, I think. Inverse. This is the actual implementation. This is the only place where I call it. So here I do a multiplication with an inverted transform, which has impact on the implementation of operator multiplication, but also on the inverse itself. So we're going to implement the inverse here by returning something where the inverted is swapped. And then I'm going to swap these two. I can even add a comment. Yes. And then let's have a look at the operator star. So here I use converted to, which in effect depends on inverted, as in if inverted is false, it is this one, and otherwise it's that one. But now I swapped them already if inverted is true. So I don't have to use this, I can just use whatever I would use if it was false. Which means the 2CS. That is the second one, which is 2 if it is not inverted. And it is going to be the from if it is inverted, if you get what I mean. I don't really myself, but I'm pretty sure that the whole idea is that I can just use 2CS now here instead of converted to. And then here we have again transform, and that is now just from CS. Yeah, so if this is not inverted, it will convert from to. And if it is inverted, it used to convert to from, but now it's still from to. So this, whatever it is a transform that transforms from to. And that's what this thing does. We go from to. So much cleaner. Yeah, that is a good change. Well, now we get the same here. What is it called? To multiply from the right. And there as well. Yeah, so we don't have another one. No, it says my around. Yep. Okay, let's do this one first then. So this is convert to, so that is to the 2CS. And this is the from, obviously. And that stays the same. Yay, awesome. And then also the multiply from the right with can be simplified. Here's again and converted to, which is done simply the 2CS. Same thing here, just always the 2. And then we have to change the implementation. No, I'm certainly not so sure anymore. It looks like it doesn't need change. That is unexpected. Maybe it's not unexpected. It might just work. The trick is, of course, that now we don't need these anymore, right? I got rid of the convert to and from. Not quite. But I should have. What is this? This is translate. To translate takes convert to. Well, not the translate is in the 2CS coordinate system. We do the translate last. That was the idea. I think the whole trick is that inverted kind of completely falls out. As in, yeah, I don't know. Simplification is almost more than expected. Translate is 2CS. It works. It just works. Great. Let's have a look at the div anyway. So I got rid of these two and then changed the meaning of from and to by doing this literally, as in if this is worded is false, then to is to and from is from, and otherwise they have to be swapped because then they are swapped. Which means that now we can use 2CS instead of convert to. And then inverse has to literally swap these two. And that's all there is to it, I think. Yeah, so the convert to becomes 2CS. And convert from becomes from CS. And this is what I was working on. And here again, convert to becomes 2CS. Convert to becomes 2CS, and the rest didn't change. And here also, convert from is now from. That's the wrong from, this from. Convert to is 2. Convert to is 2. Convert from is from. Convert to is 2. Convert from is from. That's it. So this thing now always translates 2 pixels from CS. Whether or not it is inverted doesn't really matter. Although it would be nice if we had the correct type. So let's say what I'm passing here is this, that's draw transform centered, which is not inverted, multiply with center transform pixels. Where is that defined? That's also not inverted. So inverted, non-inverted times non-inverted. The result is non-inverted. I don't see any reason then why I would have this as true. This is the default, it's false. Looks sane. So now the from and the to really have the meaning that they say they have. Therefore, the to is always intermediate. And 1 goes, the from is the first one of the left hand side matrix, is A. It says B here. Why did I type B there? This is wrong. This is A. Result is, oh, I don't know what I was thinking. I think I was confused. Yeah, this is from, this is to, so this is to, and this is result. That's the order. So this is A, B, C. Very simple. And here we have from intermediate A. So this is AB, CBA. And 2 is always intermediate. Now we have to update this. No. This is the output. Oh, yeah, well, actually, output is AC. Yeah. The left hand side is AB, the output is AC, and what we multiply with is BC. Like that. It's actually easy once you get it. So this is from C to A, and we take here the transform BA. And apparently I decided that the result should be inverted, and this is also inverted. So we have an inverted matrix, but the inverted matrix converts B to A. Yeah, that's the inverted matrix converts B to A. And we multiply that from as the right hand side of the multiplication. The left hand side is the current one, so this is from to. And that is from to, CB. And then the result is something that goes from C to A. From C to A. The outer ones. And I list them here as well. So this is simply the top one, the bottom one here, and the middle one and the bottom one here. Totally easy. And then we have the specialization for 3. So that is from C to A, which is the intermediate, as always. And the result coordinate system is the last one. That must be a B. Or is it? Yeah, it is a B. So CAB, CAB. And independent now of the booleans, we can fill this in. This is just CB, it's the top and the bottom one. And this is AB. And the first one is CA, it's the left hand side. Left hand side CA, yeah. I didn't do the booleans here yet. The way I wrote it down here is nothing is inverted. But that's nonsense. No, actually this is the one. The first one is inverted, that is the current one. So inverted must be true. What was this one? 2, it must be inverted. The first one is not inverted, here it must be inverted, and here it is also inverted. Here it must be inverted. And this one must not be inverted. And the result is not inverted. I don't know, why would it be inverted? I think the only reason I inverted it here because it looks like that's easier to compile. Either easier to calculate or. And then here we have the opposite, as in now it must be, the left hand side must be not inverted. The result is still not inverted. And the right hand side must be inverted. I mean, that's what 4 is talking about. This one is inverted and that one is not. And then we have BCA. The result is now CA. And this is CA. I wonder if this compiles. Well, I wouldn't link, of course, because I didn't implement them yet. But theoretically, it should be able to. It should be possible. I mean, to declare the specializations like this, and then I could implement them all and then merge them into one, and then using if-const expressions. And then probably it will look so simple that you think, well, why didn't you think of that immediately? And then later other people will look at that code and think, oh my god, this guy is smart. But I'm not. I had to work very hard to come up with that code and going through all this. And then I delete all the comments so that you will never be fired or the company will suffer. Just kidding. Not really. Let's compile it. Try to compile it. Totally doesn't compile. Oh, because there is no A, B, and C. No. Okay, yep, that was very smart. Well, if we fill them in, then we probably already get an immense simplification. Which is kind of annoying, because wouldn't you rather have that it is ABC all the time? Then, so maybe I should in example 2 just swap the A and the C, so it also becomes ABC. The reason I did it like this is because then I could talk about a matrix that already existed. But yeah, they are completely independent, really. So we define this as ABC, and I fill in M1 and M2. Then here's M1 and here's 1 and 2, and then we go to something completely unrelated, and I still want to have ABC. So I should just change. I have a 1 and a 2 now, and I want to completely change that, so let's change it into 3, 4. So this is now, that was 1, 2, huh? So we add 2, this becomes 4, this becomes 3, and then swap the A and the C. Replace A, replace C. Replace A, replace C. Place those, and those, and that one. Add 2. And then we get something unrelated again. Before I look at that, maybe I should update this one. So I swapped A and C. That's the only thing that's visible here. See, and now the thing looks exactly the same. I can put that in, and actually there's no difference now. In the end, it is simple. I had a feeling that would coming in the end, would be coming. So do we want to have ABC here as well? So I have to replace C with A and A with B and B with C. That doesn't sound easy at all. Can I remember that? So C becomes A. And A becomes B. And B becomes C. And we want to work here with new numbers again. So let's say 5 and 6. And that means that we have to add 2 again. Oh, I should have changed the things here as well. And I forgot what I did. I can read it from here, I think. Yeah, so I should add 2 here. Let's do that first then. This becomes 6. And this becomes 6. And this becomes 5. And this becomes 5. And then you can add 2 here as well. 5, 5, 5, 5, and the 4 becomes 6, 6, 6, and then I can probably guess where this came from, because this must be A M5 inverse B. So A, B. And then this is of course the other way around, BA. That converts A to B. B, C, B, C, A, A. Yep. Meaning that 3 now becomes also ABC. So just a rotation. So C becomes A, B becomes C, and A becomes B, C. And that was indeed what we wanted. And then here we go to yet another matrix. So we were at 6 and I need 2 numbers, so we're going to use 7 and 8. Meaning that let's I don't know, randomly 7, 8. Change the 5 into 7 and the 3 into 8. And this, I want to make this A, B, C, so I rotate the other way. Okay. Wait a minute. That's not AC then. Did I make a mistake here? Yeah, that should have been a B. It should have been a B. Okay, so A, B, C, A, C, B, C. And then they are the same again. Okay, so apparently A is always from CS. So we can infill in from CS and the result CS. To CS. Result CS. That's not what I wanted. Oh, wait a minute. I meant the C, of course. C, comma. Looks better. Right. Mm-hmm. So maybe we can define the return value, no? So we have here enable if. I mean, this is now the same, right? This part. That's the same as that one. Only the same as that one. What is then different? Oh, because of the true here, of course. Yeah, okay. So if okay, so if the right hand side is false, then the return value is, whether or not it is inverted, always false. The return value is just the same. So it is like that. This is the type. If the right hand side is inverted, is false. And if the right hand side is true, then we have these. And in that case, we also have from CS results yes. But now I have true in the case that inverted is true and false in the case inverted is false. So you might as well use inverted then here. In other words, the return type is actually inverted and RHS inverted. Only if both are true, this is true and that is true. Sorry, if this is true and that is true, this is true and that is true, then this is true. And if this is false or this is false, then it is false. Or even if this is true but this one is false, then it's also false. So this encapsulates everything. So we have now the signature for all four in one. And then we can implement all four if need be with if const expressions. Yeah, the implementation. Okay. Now there must be a return and then construct the return type, which we now already know. And that is a transform which can be constructed from a Q transform. Because it's a member function. So I'm just going to construct some Q transform. or somehow get it from the two that we have, yeah. And that now uses the same multiplication as we do, same order. So it's just m underscore times the right hand side m underscore. And this is funny because now we are going to return true here, as in the result is inverted. So the input is inverted twice. Both the left hand side as well as the right hand side are inverted. But we ignore that and then say that the answer is inverted again, then actually we just have to multiply the right hand side with the left hand side, reversed. And here I'm afraid you cannot avoid calculating an inverse. So you might as well return, if you calculate one inverse and you can't escape it, here we did not calculate any inverse, even though we had to do with 3 inverses. But here we must do one invert, and then we might as well return a non-inverted matrix. So the return type here is not inverted. This is false, because this is false. Sorry, true. So this is false. And the thing that we want is to have the current one inverted and the second one not. So that would be m dot invert. Was it invert? I don't know. Times right hand side m. No, it's inverted, yeah. That should be all then. So we must calculate A inverted times B inverted. And return that. And what we then do is return BA inverted. So a quick way to test that this is true. So, oops. I mean, it must be true, but I kind of do it intuitively for my memory. It's just not total. On my understanding is not 100%, but okay. So we can put the parentheses around this one and parentheses around this one, and then it still holds, obviously, if it holds. For the F. And again. Okay, we're done. Copy, paste. multiply this one with BA from the left and this one with BA from the left, but still hold. Now if you multiply BA with its own inverse, you get the identity. So this is equal to the identity. And here we have now B times A, that's what it was, times A inverse times B inverse. And lo and behold, A times A inverse is the identity, and B times B inverse is the identity. So this holds. Yeah. M is a private member. What you're talking about? Is this not a? Is this not a member function of transform? Are we not a friend? No, I guess we're only a friend of the template with the same template parameters. This is a templated function, which I don't know, templated member function. So the right-hand side has unknown template arguments, and then it says, yeah, well, I don't know, you can access it. Yeah, it should be. I should add a friend, I guess, for. I should add this as a friend for to this as a fucking member function. Maybe, I don't know. Add a whole class as a friend with whatever templates. Feels ridiculous. But okay. The any templates, so not the same as what we already had. Friend class transform with any template arguments. We trust ourselves. I still see this as myself, really. It's just this implementation. Who cares what the template arguments are? You can't do this. Partial template specialist cannot be declared as a friend. What is partial about that? Oh, okay, never mind. Never mind. No, I thought there was the 2 was missing. The 2 is not missing. Okay, this is weird. Should I just leave that out or something? Unbelievable. Is it gonna crash? It's not going to crash. Apparently, we now have a draw transform pixels thing. Let's just print that out when it's called here. Pass that to this function. Do here dout entering DC node this thing, some layer, comma, and then we print out this transform. Where's my entering here? Entering rectangle to window, no. Yeah, entering display coordinate system. Yeah. Some layer. This is draw 2 pixels. And it looks like that. The scale is 225. Is draw that tiny? Yes, draw is the same as centered, right? So centered is centered and runs from -1 to 1, and draw is only, yeah, here's draw. Draw, the transform between draw and centered is shifted, but the scale is 1. So the origin is shifted from the center to the top left here, but this distance is still 2. So if you go to pixels from there, then we have to multiply that by 225. And then after that, we add 200 and 175. In order to get from draw to pixels, where pixels is the top left here, I think. Well, it should be. I'm not convinced that this is 175 till there. And 200 like that. Look like a square. Oh, actually, yeah, no, the window is 600 by 450. So from here to there is 300, and this is 200 wide. So from here to there is 300 minus 100 is 200. This distance is indeed 200. while this is half of the height, which was 450, so that's 225, minus the 50 of this half width, half height, I mean, it's 225 minus 175. So this distance 175. So yes, that is indeed the correct values. Although you would wonder if this should not be negative, maybe. I don't know. But it's going towards the pixels. Sorry, towards the pixels. Yeah. No, that's correct. So if you have a 0, 0, that's the origin here of the draw coordinate. We multiply that by 225, then it's still 0, 0. And then we add 200 and 175, and then we add up in pixels in that point. It's the origin here, that point. So this is correct. Yay. And we want to use this now to draw the coordinate system, the draw coordinate system. And I want to do that here. And that's going to exist of 2 lines through the origin. I think I'm going to need a line. How does that work? Well, I had an example here. Draw a line. Let's just remove it here because we don't need it at all. And then display back here. I use that as the example. Draw a line. So we make a blue line. I don't want a blue line. I want a black line, or what do I want? No, my square is, or let's make a red line. A red line. And that was the easy part. I just changed the blue into red here. And then drawing it is probably also very easy. You just call draw layer, draw the red line. But now the stuff that we have to pass here, because I don't want to pass. Well, I want to pass. I want to create rather the origin. I want to create a point. I want to create a point in the draw. So the from CS. The from CS coordinates. And that is the origin. And that's 0, 0. And now when you want to convert it to pixels, that is the CS origin. Expressed in pixels. This is a bit CSCS, I don't like that. But yeah, that's what you get when you turn a coordinate system into an object itself. So I'll just leave it like that. Oh, wait a minute. Yeah, these are now on the other side. So this CS origin CS, which is extra extra confusing. Pixels. Sorry, this must be the... there's also CS. And now we have to multiply that with CS transform pixels. So then the CS cancels and we end up with CS origin pixels, which is what I want. But the first CS is not really... it almost looks like a transform, but it isn't because it says origin in the middle and not transform. So, you know. Or I could write this with a capital again. So like the CS origin. Maybe that is easier to understand. Now I have a point in pixels. And how did I convert that before? That was as follows. We created a rectangle. Ouch. I don't want to do that again. Well, this rectangle is constructed from a Cairo window rectangle with an automatic coordinate system conversion. So maybe I do need it. No, I don't need it because we already have pixels and I don't need to convert anything. So what this is doing here, this is converting it to pixels. That's actually converting it to centered. You gotta be kidding me. No, it's converting it to pixels. I'm constructing it from centered. It's pixels. Why the hell is this ending on centered? Pixels. So these are in pixels and now I already have them in pixels. And then we use the X coordinates and the width and everything directly in pixels. And then I create a Cairo window rectangle with the pixels. The Cairo stuff window takes pixels. Knowing that, we go back here. And we are going to have a look at what options I have to construct a line, because I don't want to have I want my line to go through a point, but then not have an end. It just mustn't be an infinite line. I'm pretty sure I have support for that. I have a math line here. This is plot, so I want to go to the draw line. Is this namespace draw? Yep, Cairo and draw line. And unfortunately, this bloody line has 2 points. Or maybe it is the line style. Doesn't look like it. We have a length and everything. I'm so confused. Yeah, well, okay. I think you have to draw lines with begin and end point always. So you need something else to put it in between. But how is that called then? Maybe the math line? This apparently not. Math line. Yeah, this is the one I want. This just goes through a point and we have a direction. So this is an infinite line. If I draw this, and I should get something that just hits the edges of the window, no? Would that only work for the plot line then? Now the plot line is a wrapper around a draw line, but okay, this thing is being constructed. Draw object, where does that happen then? Line draw objects. I don't know. A line draw object is being assigned. Yeah, this is a line piece. A line piece is something that has really 2 points. So really an XY and an XY, which come from the points that we pass or have or whatever. That is the line piece. Although, what is line extent? I think that's actually also what I need. From to, or both. I think that means that we extend it. So you have 2 points, and then if I say both, then it just continues the line. Keeps drawing beyond that point. So you can give 2 points and then say but keep drawing. Something like that. But yeah, there is a why line piece when it is not a line piece. So you can have a line piece and then extend it. A line should this always be extended maybe, or I don't know. I completely forgot. Trying to find out though. The other one is line draw object. Yeah, also converts 2 points. Oh, intersections. Yeah, this is what I want. And that is plot, unfortunately. So we don't have that. Ouch. Yes, okay, so this calculates intersections with the plot boundary and then draws still the end of the plot. And I was confused, thinking that we could draw a line till the end of the window, but that's not supported, unfortunately. Suppose you can create a rectangle and calculate the intersection, so just copy this code. Calculate the intersections with the rectangle that spans the whole window, and then draw the lines till there. Basically copy this, yeah. Except that then the rectangle must come from not a range, but from the window sizes. If everything is in pixels, it isn't too hard. This is 0, and this is 0, and this is the window width and the window height. I think we can do that. How much magic is involved here? In the end, we end up with a shared pointer. I guess that doesn't matter. I can just make it a boost intrusive pointer instead. What I really need is this. And the line style, do I have a line style? I'll have to create one, I'm afraid. What is this line here? Is that a plot line? Probably. Yeah, it says so, plot line. But the plot line was derived from the math line. So we can forget about plot and then just use a math line here. This is a plot line, it's derived from a math line. Maybe copy this whole function and then rework it a little bit. Quit. Okay, so we have the boost intrusive pointer to the GUI in the layer. That's the same object, so we can just pass that. That is our layer, and then we have, well, we need a line style. Well, this thing is going to draw very long lines then, always till the end, or Do I want to draw half line sometimes? I don't know yet. Anyway, this function does not necessarily have to decide on the line style. So let's pass a line style. And that is then must be a draw line style apparently. And do I already have a line style? And is that also a draw line style? I think it is. Line style. That's what it took. How does that even compile? Probably doesn't. I never tried to compile it. Here's the line style. Yeah, that's gear window draw line style. So we can use that here as well. Then it does compile. And we're going to pass that to this function. Therefore, this is the Cairo window draw line style. This is not plot. And this is a display line, free function, number 20. And then we need a math line. Cairo window direction. You can get the direction from the math line. Cairo window point. There you can get a point, I hope, from the math line. Is that true? So we have a Cairo window point. Draw coordinates. I don't know. Let's do this namespace Cairo window. I hope not. Yeah, okay. Cairo window point is a math point. Doesn't get any easier than that. So we should be probably more worried about the direction. That Cairo window direction is a math direction. Okay. There we go. So it's just why would I even call it Cairo window then? Normal X, well, I don't see a reason, I don't understand this, but I don't see a reason to change it. Oh, that's the X coordinate of the normal. Yeah, now I get it. And the other one, intersections, where does this come from? There's also, oh, there's a namespace intersections. Intersection points. Well, might have to include this header. I don't know, maybe. It's kind of literally being used here. Let's just include the header. Let's just include the header. Sections, hyperplane, double to line, normal X, normal Y, point. You have the point, you have everything. It's just do your magic. Make the rectangle, and now we have the range. Okay, so here we use, well, the minimum of my x-axis in pixels is obviously 0. And the minimum of the y is 0. And the max is then the window width. And the y is the window height. Because this hyperblock is created from a vector type, two vector types. The vector type is actually a vector float type. Vector flow type 2. So the hyperblock is a double, I think. Not really necessary to use double, but well, why not? So we have a vector double 2. It's being passed. Well, the vector is defined also here. Elements of the vector. Okay. Very simple vector. Calculate the intersections from that. It should also work still out of the box. It's very little that I have to change here. Interesting. Is the line outside the plot area and then we draw nothing? Well, that would work, I think. You just return from display without displaying anything. Otherwise, get intersection points and then we can use that. And I have a convert here, but I don't need a convert, I think, because everything is in pixels already. We should pass pixels here. The convert is more a plot thing. Of course, you have plot coordinates and that they are converted here to window coordinates. But my pixels are actually window coordinates. So that should do the trick, except that we want to do the same thing as down here, not down there. Here was my example. Draw a line. No, it's what? Make shed. So layer draw takes a standard shared pointer. Layer draw. Huh? Yeah, standard shared pointer. Thought it would have been a boost intrusive pointer, but it's not. The rest are just namespaces. A lot of namespaces. I'll never call a function draw again. It was getting dizzy. And it goes on and on and on and on and on and on. Oh, that's the end. Okay, so yeah, so we need a shared pointer. And our line can be created from, well, the way we do it here. Actually, we won't do it there, we just do it here. And that line should be a Cairo window line. Cairo window draw line, I mean. And then we assign that to yeah, let's just call it draw object. Maybe lame, but draw layer region on is definitely not the way. I'm just gonna call it like that. Draw object. Yeah, just gonna pass it directly. That transfers the ownership, no doubt. So this should make our line visible. if you call this function, that is. So now I need a math line, and then I can draw it. That is, we call this passing the layer, and then pass line style, which you have to make up. Well, that was this. Let's pass this line style. So now it's red indeed, with a bit of 1. And then we pass a math line, which can be constructed from something. So what does my math line now look like? How can we construct a math line? The math line is defined as draw line, math line. It can be constructed from the point that it goes through and a direction. Well, the point I already have, and then we need a math direction, which is also super easy, obviously. Because, well, maybe I now have to take a rotation into account, so not that easy. But we just calculated the point. So the math line is calculated from, and I've got it again. Oh, well, no, not really. A math, well, some point, a math point. Let's just do that first. Can I make a math point? So the line goes through this point, and we have a math direction. That draws a red line through that point in that direction. And this point, no doubt, can be constructed from an x and a y coordinate. What is this? I need okay, a window point. This is a plot point. No, just a math point. The math point is probably just a double x and y. What else can it be? And that is in pixels. We work in pixels in math and in Cairo window. And the pixels we just calculated. So this is x, comma y. Now it's going through the CS origin, and the direction, the direction I think should be a unit vector, although I'm not sure anymore. It's a math direction, so you have an up, down, left and right. That would be easy. Direction up. Well, I can use direction up for now, because it is pointing up. In the end, we have to apply some kind of rotation, though. I'm starting to be curious if the rest is working, and I want to go to bed also. It's the only constructor. This is math direction. Okay, we can construct a math direction from another point, or from a line piece, from a line. Normal inverse, normal inverse. From an angle. From another point is probably the easiest. I could take any point that is not the origin. and then apply coordinate transformation to it. So it's 0, 1 or 1, 0 for the y-axis or the x-axis, and then rotate. I will apply the rotation to that, or the whole whatever transformation, and then we just have a point on that axis, which gives us the direction. That should be good enough. So really I want to have some point, and then we can create the direction from the point on the axis that we want to draw. So yeah, I'm just drawing one line at the moment. I'm going to have to draw 2 lines. So this point should probably be called origin. And this, let's call this on the x of the, let's start with the y direction, And the y direction can then be constructed from, let's say, the point, the point 0, 1. And then the point 0, 1 must be a math point, which we also have to construct from an x and a y, and also must be pixels. So I want to have the CS 0.01 in pixels, x coordinate, and the CS P01 in pixels, y coordinate. This is the 0, 1 point. The 0 and 1 is in CS coordinates. Maybe like that. But it is obviously again pixels. I'm going to straight for the 1, 0 as well. Going to need a 2. So we need now this, which looks very much like a point in pixels, because you know, pixels. So this is pixels. This is the coordinate system point at 0, 1 in the pixel coordinates, which obviously means that we have to multiply something in the CS, in the form CS. Zero comma 1 with the transform that transforms it to pixels, and the other one is then 1, 0. Well, this was like that, and this is like that. And the origin, well, I might as well do the same thing here, I guess. Don't need this origin again. I'm gonna add cons because I do not intend to change it. The X and Y direction, no, the X comes first. And let's draw two lines, both through the origin, which is called origin now. With direction. This is now, well, it doesn't matter. Draw a line in the X direction and a line in the Y direction. My god, if this is going to compile, I'll sleep like a baby again. Math direction. It doesn't know what Cairo direction is. I have to include Cairo direction. Yeah, well, maybe not. Maybe we should just use math here. Who cares? Incomplete math line. Interesting. Error redefinition of line of different type. Oh. Yeah. Nah. How about an underscore? Color is unknown. Did you mean yes? Is that the one? Or is it this one? Oh, that's pointing to nothing. This should be a draw. Still color unknown. No, something else. Well, not quite. Use undeclared identifier color. Yep. Actually, we need that one. Namespace color. I had a line style and a line, and the rest is in math. point. Oh, point. What point is this? Oh, this is my own point. Yeah, okay. Ding, 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 ding. No magic constructor initialization of line style, aka window draw line style. It just doesn't know what I mean with this, I think. Yeah, I don't even know myself. A math line, wasn't it? Display line. Wait a minute. Display line doesn't know that. That would be kind of weird though. So make G tags. Display line. I defined it up here and it just takes a math line. So what is your problem? It's totally known what I mean. Construct me a math line. So it doesn't want to do that. Well, tell me why. Math line, please. Oh, I included it. It's included in the line style. That wouldn't work. Line style. It must end. How does that work? How many line styles do we have? It's the only ones. What? Oh no, let's hope that this works. It seems to work. I'm so curious if this works or not. So curious. And it doesn't. Unfortunately, I have to go to bed. Yeah, I'm going to bed. Tomorrow, another day. I mean, the next step is just printing everything we can print again as debug output and then see from the debug output where the line is, and it's probably then far outside of the window, and then track down which conversion goes wrong and blah 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 blah, and then fix that. And we did that before also with the rectangle, but now we have to do it with the line. Nothing can work immediately. It's amazing. Good night. Thank you for keeping me company.